Yeah, good evening, everyone. Good evening, everyone. Yeah, good evening, everyone. Good evening. Let's start the class. Let's start the class. Let's start the class. Yeah, good evening, everyone. Good evening. This is the first problem. Yeah, this is the first problem. So this is the first problem. Can you read this problem? This is from combinations. This is from the yeah. What will be the answer for this? So I'm reading the problem. I'm reading the problem. 7 digits. The first two of the inclusive means you can include 2 also, you can include 9 also. The third digit between 1 and 9 inclusive, and each of the remaining between 0 to 9 inclusive. What will be the answer? This is the first problem of today's class. How many possible telephone numbers are there with 7 digits? The first is between 1 and 9 inclusive, and each of the remaining between 0 to 9 inclusive. What will be the answer? Can you give the answer to me? What is the answer for this problem? Yeah, fine. Can you give answer for this? How many possible telephone numbers are there with 7 digits? So 7 digits. With 7 digits. The first two of them are between 2 and 9. Remember, 7 digits. 7 is saying that the first two of them are between 2 and 9 inclusive. 3, 4, 5, 6, 7, 8, 9. 8 people. Otherwise, you can use formula because of inclusive plus 1 also you can write. 9 minus 2 will give 9 minus 2 will give before 9 how many, including 9 also. So 9 minus 2 is 7 plus 1. So 8 people are there. 8 people are there. So the first possibility, 8 possibilities are there. The second one also 8 possibilities. First two, right? 2 of them are between 2 and 9. First two inclusive, so 8 possibilities. But if you see the third one, the third, right? The third 1 and 9 means I think. Otherwise, you can count manually also 1, 2, 3, and so on 9. Next one, each of the remaining between 0 to 9. Each of the remaining is remaining 4 people. Each of them means, right? Each of them is 0 plus 1, 10 people. So I think everywhere 10 possibilities. Everywhere 10 possibilities. The possible number of telephone numbers are answer 8 square into 9 into 10 power 4. This is the answer. Ask me, I will help you. And so that is the thing what Upadhyaya is saying. So if I make Upadhyaya full course on the YouTube, right, I will become Bikari. Right? I want to make full course only. But if I make lies also, right? So it's not possible. I want to do, but I cannot do because no one will buy our course, right? So definitely I will become victim. So it is really not possible. I cannot take for asking. Yeah. Is there anyone who is having doubt in this problem? Two of them between 2 to 9, which are 8 possibilities. Remaining are right normal. So 10 possibilities both can be done. M into n ways, n into n ways. So finally square into 9 into 10 power 4. I hope everyone got. I hope everyone got. We can go to the next problem. If you are okay with this problem, we can. How many integers between 8 and 1 9? Again, how many integers between 1 and 10 power 5 contain exactly 1 8 and 1 9? Exactly 1 8. Please let me know what is the answer for this problem. Please let me know this. Yeah, what is the answer for this problem? How many integers between 1 and 10 power 5 contain exactly 1 8 and 1 9? If anyone can give answer, please let me know. Can you type in the comment section? Can you type in the comment section? Exactly 1 8 and 1 9. So I think you know very well. You know very well. 1 and so I think less than 10 power 5. 10 power 5 means almost like right. I think 10 power 5 means 5 times. I think 6, right? 5 zeros, 1 lakh. So larger number is right 99,999. I think 5 digits. 5 digits are there. 5 digits are there. How many integers between 1 and 10 power 5 contain exactly 1 8 and 1 9? So I think 10 power 5 means I think 5 zeros are there. 5 zeros are there, right? So I think between, he is saying between. So the larger number is between. So I think it is a 1. So between means this 2 2. 99,999. So I think larger number contain 5 digits. Let's talk about where 8 can go. Let's go 8 can go among all these 5 places. Anywhere it can go. 8 can go 5 places. 8 can go 5 places. 9 can go 4 places. Out of these 5 people, 8 can go anywhere. 8 having 5 possibilities. 9 having 4 possibilities. You can select wherever. 9 can go to 4 places. Suppose if you take the 9 9 more places. I think right, 5 into 4, 4 into 5, both are similar. So here 5 possibilities, here 4 possibilities. Then who can come here? Who can come here? Who can come here? Everyone know 8 and 9. See, exactly 1 8 and 1 9 already came. Exactly 1 8. So what is the answer? I think here 8 possibilities. I think here also 8 possibilities. Here also 8 possibilities. You may say that, sir, and so on 7. 0 to 7, 8 possibilities. So the final answer is going to be 5 into 4 into 8 cube. 20 into 8 cube. This is the answer for this. If anyone having any doubt, please let me know. How many integers between 1 and 10 power 5 contain exactly 1 8 and 1 9? So 8 can go to how many places? 5 places. 9 can go to how many places? 4 places. Right? Remaining 0 to 7, anyone can come. So 8 possibilities, 8 possibilities, 8 possibilities. Right? Please let me know. Right? Let me know. Anyone having any doubt? How many integers between 1 to 10 power 5 contain exactly 1 8 and 1 9? 8 having 5 possibilities, 9 having 4 possibilities. Remaining all, if you see, 8 8 possibilities. So totally 5 into 4, 20 into 8 cube. So you may say that, sir, can I keep the 8 in the last place? Yes, that is the reason 8 having 5 possibilities. You can keep it anywhere. You can keep anywhere. Can I keep the 8 in the last place? Yes, you can keep, no objection. That is the reason 8 having 5 possibilities. 9 having 4 possibilities. Sir, if you keep the 8 and 9 in the last places, in the first places 0 also will come. It's okay. Let it come 0. What is the problem? Let it come 0. What is the problem? Now I think some people are asking, sir, you have to see, right, how many numbers contain 5? Exactly 1 8 and 1 4. It is maybe 8 9. First 3 places 0. It may be 9 8. So I taken care about 2-digit numbers also. So whenever first, right, initial 3 people are 0, 2-digit numbers will come. 8 9 also, 9 8 also. Those also I see this one. First 2 people 0. First 2 people 0. It may be 189. It may be 289. It may be 389, and so on and so on. Next one, in the similar way, it may be 198. All possibilities are taken care. All possibilities are taken care. If anyone feel any, please let me know. I will help you. Anyone, sir, I have this doubt, sir. You ask me. The purpose of live class is, if you have doubt, you can ask immediately. The purpose of live class is, if you have any doubt, you can ask immediately. Sir, I have this doubt, sir. You ask immediately, I will help you. That is the purpose of live class. That is the purpose of live. Please let me know, sir. I have really this problem. Can I move to next problem? Can I move to next? Can I move to next problem or not? Please let me know. Those people who are preparing for GATE 2025, those people who are preparing GATE 2025 are UGC NET, are placement training, or PSU exams, new batches are starting. You can go to exampreptool.com. From there, you can join. If you have any doubts, right? If you want to clarify any doubt, you can WhatsApp us this number. We are going to help you. Please let me know if anyone having any doubt. Yeah, let's move to next problem. Let's move to next problem. Let's move to next problem. Yeah, can you help me? What is the answer of this? Please check properly. It's a very interesting problem. It's a very interesting problem. Can you check properly this one? If you want, I will read also. If you want, I will read also. Let me read it. How many ways we can distribute 100 prizes among 3 students? How many ways we can distribute 100 prizes? I written already, right? 100 prizes. I written prize 1, prize 2, prize 3, and so on, right? P1, P2, P3, and so on. P100. There are 100 prizes are there, right? You have to distribute among 3 students. Students are S1, S2, S3, and condition is, if you see the condition, each student can take exactly one prize. You don't take, right? If you take one student, you don't take more than one prize. Every student can take maximum one prize. Each student can take exactly one prize, not more than one, not less than one. Which prize you will take? S1 student may take prize P100. S2 student can take prize P1. How many ways we can distribute 100 prizes among 3 students? The condition here is each student can take exactly one prize. Can anyone help? What is the answer for this? Can you comment in the comment section? Sir, I have this doubt, sir. You ask me, I will help. Don't sit like a stone. Don't sit like a stone. Whatever doubt you have, please post in the comment section. Comment section, I will help you. Anyone? Those people who are having doubt, those people who know the answer, can you type in the comment section? What is the answer for this problem? Each student can take maximum. Each student can take exactly. Students are S1 to S3. Anyone? See, not only watching one, not only watching. Please, can you respond? So, what is the answer? So, if you see the answer, student S1 can take any prize. So, I think let the student S1 taking prize P100, S2 taking, right? I think prize may be P5. S3 is taking prize may be P1. We can distribute. One more thing is remember, P1, P5, P100 also. One more thing is P5, P1, P100 also. So what I mean to say is order also important. Order also important. Remember, order is important. Order is important. Remember this. Order important means that is called permutations. Order important, that is called permutations. Order is not important, that is called combination. 100. Right? For the S1, are you giving P1? So remember P100. So remember everyone. P100, P5, P1. Next one P5, P1, and P100. P100. Remember these three are one combination only. It is a one combination only. But remember these are three permutations. Permutations means order is important. So some people are asking, then how many ways I can keep here, sir? Sir, how many ways I can keep? So what is the answer? I think 100 prizes you can do. For S1, out of 100 prizes, you allocate anything. One out of 100 think one person to S1, I think he's having 99 because one prize already given. Let us enter P100 I already given for S1. You cannot give P100 to S2. So it is a 99. It is going to be 98. 99 into 98. And remember everyone, out of, right, see this one, first person for the first student, out of 100 prizes, one of the prize you can select 100 ways. For the second student, out of 99 prizes, one of the thing you can select 99. For the third student, out of 98, you can select one of the prize. This can also be written as out of 100 people, out of 100 people, selecting three people, where order also important. This is also called 100p3. This is also called 100p3. Some people by 100 minus 3, 97 factorial, which can also be written as 100 into 99 into 98 into 97 factorial by 97 factorial. 97 factorial, 97 factorial cancel. 100 into 9 100p3. Remember, it is a 100p3. It is not 100c3. It is not 100c3 because 100c3 means 100 factorial by 100 minus 3, 97 factorial into 3 factorial. That is the meaning of 100c3, which is going to be 100, right? Which is going to be, let me write now, 100 into 99 into 98 into 97 factorial by 97 factorial. Both are cancelled, but there is a 3 factorial also. So this will leads to 100 into 99 into 98 by 3 factorial, but there is no 3 factorial. So this is not. Remember, right? Remember, combinations different, permutations different. Remember everyone, combinations different, permutations different. Combinations different, permutations different. Order important, permutations. Now one more thing if you observe, this is the formula between both of them. Can you see the formula? See the formula. This is the formula between them. NCR is equal to n factorial by n minus r factorial. This is the NCR formula. Right? NPR formula, if you observe, n factorial by n minus r factorial. That's it. So if you observe clearly, NPR, right? If you observe clearly NPR, NCR, in the NPR below there is no r factorial, but in the NCR r factorial below, because the below r factorial, NCR is smaller. Right? Now see this one. See everyone now. So this NCR, if you multiply by r factorial into NCR, I think this r factorial, that r factorial, both are cancelled. It will become NPR. Remember, for the smaller one, if you multiply by r factorial, then you will get the NPR. NPR means bigger. NPR bigger. This is the relation between both of them. Order important. Please go for permutations. Order is not important. Then go for the combinations. Right? Because of in the NCR, right, order is not important. So less will come. In the NPR, order is important. More will come. I hope everyone got it. I hope everyone got this. So please check here. How many ways we can distribute 100 prizes among 3 students? Right? So remember, it is 100p3, but it is not 100c3. 100 C3 means 100 into 99 into 98 by 97 factorial. 97 factorial and 97 factorial both are cancelled. 3 factorial is below left out, but there is no 3 factorial below. So it's actually NP3, 100 P3. Right? Fine. Fine. Now let's move to the next problem. Can you try in the similar way? What is the answer of this problem? Can everyone try this? Can everyone try this? How many ways we can generate number plates with 3 characters, case sensitive, and no repetition? What is the answer? Please check once again this problem. One more opportunity to you. How many ways we can generate number plates with 3 characters, case sensitive, and no repetitions? 3 characters are there. And case sensitive, small is different, big is different, small different, big different. I think 26, 52 letters, 3 characters, 52. No repetition. Repetition is not allowed. Repetition is not allowed. So what is the answer? I think here 52 possibilities. Because of repetition not allowed, 51. Here 50. 52, 51, 50. No repetition is allowed. Case sensitive, 52, 51, 50. And one more thing, let me say this one. Out of 52, everyone out of 52, assume it is a AB. It is a ABC, assume. ABC is one group, right? ABC is the one way of generating. What is this one? How many ways we can generate number plates with 3 characters? 3 characters only. So it is a one number plate ABC, right? BAC also one more number plate. One more thing is CBA also one more. Order important. Order is important. So permutations. So I think this can also be written as finally 52 into 51 into 50. This is also called as out of 52 people, right? I think permutations of 3. 52 P3. Out of 52 people, selecting 3 people, but order also important. 52 P3. So which can also 52 P3 means, I think if you want, you can verify. Same thing. 52 factorial by 52 minus 49. 49, right? So I think below 49 factorial, above 49 factorial, both cancel. 52 into 51 into 50. So, but remember everyone, right? This is not 52 C3. It is not this. Order important. For the first place, 52 possibilities. Second one, 51 possibilities. Third one, 50 possibilities. One work will be m ways, another work will be n ways. Both can be done at a time. M into n ways. 52 into 51 into 50. So which is nothing but out of 52 people, selecting 3 people, where order also important, so permutation. Those people who are watching, please can you respond? Please can you respond? Are you getting or not? Please let me know, are you getting or not? Those people who are watching, please let me know, are you getting or not? Let me know, are you getting or not? If you are preparing for GATE 2025, GATE 2025 or GATE 2026, right? So for UGC net also, GATE exam also, placement training also, right? PSU exams also, new batches are starting. You can visit exampreptool.com or you can WhatsApp us, right? So my suggestion is, without wasting time, please start as early as possible. Please start as early as possible without wasting the time here and there. Please start preparation as soon as possible. Our team is going to help you. Our team going to help you without wasting time here and there. My request to everyone, right? Please start the preparation as soon as possible. Yeah. Let's move to next problem. Let's move to next problem. Yeah, let's move to next problem. Yeah, what is the answer of this problem? Two problems I written. Can you solve these two? How many ways? How many ways are there to distribute 10 different books among 15 people? How many ways are there to distribute 10 different books? 10 different books. So I may give the names. I may give the names. 10 different books. I may give the names. Book B1, book B2, book B3, and so on. Book B10. Between 15 people, person P1, person P2, and so on, person 15. No person can get more than one book. No person can get more than one book. Right? I think if you observe clearly, I'm just giving idea. There are 15 persons are there, P1, P2, P15. P1, P2, and P15. There are 15 people are there. Out of those 10 books, one of the book you can give here. One more book maybe B9 is here. One more book maybe B3 is here. Like that you can allocate. Remember, person P1 having B1, person P2 having B9. So I can give differently also here. So I think order is important. P1 having B1, P2 having B9. Otherwise, P1 having B9, P2 having B1. Order is important. Order is important. I think because of order is important, the permutations. So I think the possibilities are, I think all can come here. The possibilities are all can come here. The possibilities are here 9, right? And so on and so on. So please let me know what is the answer. Some people are asking, sir, can I give? See, no person can get more than one book. Remember, no person can get more than one book. Out of those 10 book, one book give to P1. Remaining 9 book, one book give to P2, and so on. There are 10 books are there. So I think first person have 10 choices. One of the book they will get. Second one having 9 choices. One of the book will get. Please let me know if anyone having any doubt. Let me know. Check anyone having doubt. So what is the answer for this? Anyone? So let me try this. So there are 15 people, there are 10 books. 15 people, 10 books. Where book B1 can go? Can you help me now? Where book B1 can go? Book B1 can go. Book B1 can go. Anyone. It can go to anyone. Book B1 can go to anyone. Book B2 can go to where? Other than that place, any place. Fine. So I think, yeah, we misunderstood the problem. So please see once. Please see once. This is the problem. How many ways are there? Right? This problem we misunderstood. Right? So let's see once again. How many ways are there to distribute 10 different books? How many ways are there to distribute 10 different books among 15 people? Among 15 people, no person can get more than one book. That is a given problem. Persons are P1 to P15. Books are B1 to B10. Now, can you help me now? Where the first book can go? Where the first book can go? First book can go out of these 15 places. Anywhere he can go. First book can go out of these 15 places anywhere. Anywhere it can go. Let us assume that B1 is came here. First book B1 can go to out of these 15 places. Anywhere it can go. Right? Next one. Where B2 can go. So here 15 possibilities are there. Where B2 can go. Other than that place. Because no person can get more than one book. No person can get more than one book. So I think B2 can go other than that person anywhere. Maybe B2 here. I think it is a 14 place. 14 possibilities. So it will continue. It will continue. 15, 14, and so on. What is the answer? 15, 14. So just to do 1, 1, 1, 1, 1, minus 1, minus 1, minus 1. I think what is the answer? 15 minus 9. I think 6. So it will be there 6. Check properly. Right? So I think answer is going to be same story. Answer is going to be 15 into 14 into 13 into and so on 6. So which is also called as 15C10, which is equal to 15P10 because order is important. So remember why order is important. Let us assume that it is a B3. Why order is important? It is a B1, it is a B3. Order important. So 15P10, which is nothing but 15 into 14 into and so on. And so on. Let's see this one. And so on. Right? 6 into 5 factorial by 10 minus 15 minus 10. 5 factorial. Both are cancelled. So same answer. So please try to remember. So don't right. Initially I misunderstood. Right? So please careful. How many ways are there to distribute 10 different books among 15 people? 15 people P1 to P15. 10 books B1 to B10. So where book B1 can go out of 15 people anywhere? Assume that B1 went to here. So the possibilities for B1 is 15 possibilities. Where B2 can go, right? I think because of every person can get maximum one book. So B2 will go other than. Assume that it went to the 50. Where B3 can go, where B3. So I think 13 possibilities. And so on, continue. And so on, continue. So you may say that, sir, why 6, sir? Last one is 10th one. 10th book can go to where? It is having only 6 possibilities. It is having only 6 possibilities. So the reason is you may say that, sir, how it is possible? Very simple. It is almost like 15 minus 0. It is a 15 minus 1. It is a 15 minus 2. 1 decreasing. And so on. Lastly, 15 minus 9. See, 0 to 9, 10 people. 0 to 9, 10 books. 15 minus 9 is 6. So finally, this is the answer. It's very simple answer, right? Continuation of the previous problem. 15P10. Answer is 15P10. How many ways are there to distribute 10 different books among 15 people? Right? So this is the case. 15p10. I will rewrite again. 15p10. Right. Perfect. Perfect. Let's go to this problem. Yeah, let's go to this problem. A group of 8 students are there. Sorry, a group of 8 scientists is to, right? Remember, it's the next problem. The next problem, please take care. A group of 8 scientists. I'm starting the another problem. So please careful everyone from now onwards. Please careful from everyone. Right? This is another problem. A group of 8 scientists is the combination of 5 psychologists and 3 sociologists. A group of 8 scientists is the combination of 5 psychologists and 3 sociologists. Then the question number 1 is asking how many ways we can make committee of 5 scientists will be formed. How many ways we can make committee of 5 scientists will be formed. So you have 8 scientists, which is a combination of 5 psychologists and 3 sociologists. You have to make from those 8 people committee of 5 people. So I think out of 8 people selecting 5 people, 8C5. Here I think order is not important, so happily you can go for combinations. Out of 8 people selecting 5. Where is the order important here? Where is the order is important? So 8 scientists are there. See this one. Scientist 1, scientist 5. Scientist 5, scientist 1, both are same. A group of 2 people. S1, S5, S5, S1, both are same. Your order is not important. So that is the reason 8C5. Next one. How many ways we can make a committee of 5 scientists, in which 3 psychologists will be there, 2 sociologists will be there. How many ways we can make committee of 5 people, in which 5 are psychologists? Sorry, in which 3 are psychologists, 2 are sociologists. Then what is the answer? I think if you observe clearly, you have to make committee of 5 people. In that 3 are psychologists, but actually out of 5 psychologists, you have to take only 3. 5C3. Next one, 2 sociologists you want, right? So out of 3 sociologists, you want to 2. 3C2. 5C3 is going to be 5 into 4, right? 5C3 is going to be 5 into 4 into 3 by 1 into 2 into 3. 3 cancel. So 10. Right? So 3C2 means 3 into 2 by 1 into 2. 2 cancel. So 3. I think 10 into 3, I think 30. 10 into 3. So just to calculate, this is going to be 30. So just the purpose of this problem is, here there is no requirement of order. I want to say these are combinations. Here there is no requirement of order. Just combinations. Right? Here there is no requirement of the permutations. Only combinations. Right? I hope you got all these things. This is the next problem. This is the next problem. In how many ways, right? This is the next problem. Right? I done also for your convenience, I done also pre-check. In how many ways can 6 boys and 5 girls sit in a row? Right? So I think it is one more problem I want. So anyhow, what I will do is, these are the answers I already done. Let me explain. I already done the answers also. Let me explain. See the problem. In how many ways can 6 boys and 5 girls sit in a row? 5 boys and 6 girls, you want to sit them in the row. So no order, nothing there. So totally 5 plus 6 people, 11 people. 5 plus 6 people, totally 11 people. 11 people can sit whatever order they like. 11 people can sit whatever order they like. Remember 6 boys. B1, B2, and so on, B6. I think 5 girls. G1, G2, G3, and so on, G5. Remember, B1, G1 different, G1, B1 different. Your order is important, so factorial k. Total 11 people, they can sit in any order. Your orders are important. Your orders are important, so 11 factorial. You cannot say B1 G1 is equal to G1 B1. You cannot say that. Next one. In how many ways? 6 boys and 5 girls can they sit in a same row? If right, the condition is all boys followed by all girls, or all girls followed by all boys. Same thing like above. 11 people should sit in the same row. That is the condition. But boys followed by girls, or girls followed by boys. Suppose boys followed. Suppose assume that boys followed by girls. Within the boys, how many ways? 6 factorial. Followed by girls, 5 factorial. Suppose if it are girls first, 5 factorial, followed by 6 factorial. So 6 factorial into 5 factorial, 5 factorial into 6 factorial. So both, I think, right, multiplication, A into B is equal to B into A. 2 times of this. 2 times of this. Right? So the purpose of this problem is, in this problem, I want to say order is important. B1, G1 different, G1, B1 different. Order important means factorial will come. Means permutations will come. Permutations will come. So these are the permutations. Order important means permutation. Right? 6 people, how many ways you can arrange? 6 factorial. 5 people, how many ways you can arrange? 5 factorial. 6 factorial by 5 factorial, 5 factorial by 6 factorial. This is the one more problem I want to clarify. So I done it. I hope this class will be useful to you. Right? So see you in the next class. Right? Thank you so much. Thanks everyone. Thank you so much.